When you type a question into a chatbot like ChatGPT and get a coherent, often surprisingly insightful response, have you ever wondered how it knows what to say? How does a machine learn to communicate like a human? The answer lies in one of the most remarkable processes in modern technology: how AI chatbots are trained. Let's start at the beginning. Data. Every AI chatbot is powered by a large language model, LLM, and training an LLM requires a massive amount of text data. This data typically comes from the internet: books, articles, websites, code repositories, and more. The goal is to expose the model to the structure, grammar, and semantics of human language. It learns from everything it reads, but not in the way humans do. AI doesn't read for meaning. It reads for patterns. A chatbot like GPT is trained using a method called unsupervised learning. It's fed enormous amounts of text and learns to predict the next word in a sentence, one word at a time. For example, if the prompt is, "The sky is," the model might predict blue because it has seen that combination of words many times before. This is called language modeling, and it's the foundation of how AI learns to generate text. The model doesn't understand the text. It statistically predicts what comes next based on patterns it has seen before. The architecture that makes this possible is called Transformer, introduced by Google researchers in 2017. Transformers allow the model to pay attention to different parts of a sentence when predicting the next word, making them far more effective than previous models like RNNs or LSTMs. Next comes the training phase. Training a large-scale chatbot model involves running computations on billions or trillions of parameters. These parameters are the internal knobs the model adjusts as it learns. The model processes tokens, chunks of text, and updates its parameters to reduce the difference between its predicted outputs and the actual data. This process is computationally intensive and typically takes place on massive clusters of GPUs, often powered by NVIDIA chips. It can take weeks or months, cost millions of dollars, and require cutting-edge hardware infrastructure. But training on raw internet data isn't enough. Once the base model is trained, developers fine-tune it using additional methods. One key method is BAS, supervised fine-tuning, where human annotators provide example prompts and ideal responses. The model is then adjusted to mimic this higher quality behavior. Another powerful technique is called reinforcement learning from human feedback, RLHF. Here's how it works. 1. Humans rank different model responses to the same prompt based on quality. 2. These rankings are used to train a reward model that scores how good a response is. 3. The chatbot is then fine-tuned using reinforcement learning to produce higher scoring outputs. This process helps align the chatbot's behavior with human preferences. It makes the model more helpful, less likely to produce offensive or nonsensical answers, and more aligned with ethical guidelines. At this stage, the chatbot begins to resemble what we interact with today: a conversational agent that seems to understand, empathize, and inform. But there's more. Chatbots also go through safety training, where they're taught to avoid harmful topics, reject inappropriate requests, and stay within certain boundaries. This is achieved through curated datasets, adversarial testing, where people try to break the model, and filters that block unsafe outputs. Then there's instruction tuning, a method where the model is taught to follow commands more accurately. Instead of just predicting the next word, it learns how to respond to tasks like summarize this article or translate this sentence. This makes the chatbot more usable for real-world applications. Once trained, the chatbot is deployed through an API or a user interface, like a mobile app or a browser chat window. But training doesn't stop there. The real world is dynamic. People use chatbots in unexpected ways. That's why developers often collect anonymized feedback to monitor performance, spot failure modes, and retrain the model periodically. This is known as continuous learning, and it's critical for keeping the chatbot accurate, up-to-date, and aligned with societal norms. So, how is a chatbot evaluated? Researchers use benchmarks like Blue scores for translation quality, Truthful QA to test factuality, MMLU, Massive Multitask Language Understanding, to test knowledge across domains. They also rely on human evaluations, which are often more nuanced than automated metrics. These tests help ensure the chatbot is not just fluent, but also accurate, helpful, and safe. But even with all this, chatbots aren't perfect. They still hallucinate, making up facts that sound plausible. They can reflect biases present in their training data. They may misunderstand context or deliver overly generic responses. That's why transparency in training methods and data sets is crucial. It helps users understand what a chatbot can and can't do. The future of chatbot training may include multimodal models that understand images, video, and audio. It may involve memory systems that remember past conversations and personalization layers that adapt to your style and preferences. We may even see on-device training, where your chatbot learns from your behavior while preserving your privacy. In the end, training an AI chatbot isn't just about algorithms and GPUs. It's about capturing the essence of human language, behavior, and thought, and translating it into something a machine can use to assist, inform, and connect. And that journey, from raw data to intelligent dialogue, is one of the most complex, fascinating processes in modern AI. So the next time a chatbot answers your question in seconds, remember, behind that response are millions of lines of code, terabytes of data, thousands of human judgments, and years of innovation in AI training. Let's explore some of the lesser-known but equally important components that go into chatbot training. One such area is tokenization. Before a model can process text, it must break it into manageable pieces, called tokens. These might be words, subwords, or even characters. The model doesn't read apple as a single concept. It might break it into app and lee. Efficient tokenization helps compress information and improves learning. Another essential concept is pre-training versus fine-tuning. Pre-training is where the model learns general language knowledge from a broad corpus. It becomes proficient in grammar, facts, reasoning, and style. But to make it useful for specific tasks, like answering questions or assisting in customer service, developers perform fine-tuning. This tailors the model for practical use. There's also a concept called zero-shot and few-shot learning. Zero-shot learning is when a chatbot can handle a task it's never seen before, just by understanding the instruction. Few-shot learning involves showing it a few examples and expecting it to generalize. These abilities highlight how flexible and powerful modern chatbots have become. Training also includes regularization techniques to prevent overfitting. If a model memorizes its training data too closely, it won't generalize well to new prompts. Developers use dropout layers, data augmentation, and loss function tuning to strike the right balance between learning and flexibility. On the ethical side, chatbot training often incorporates differential privacy, where noise is added to training data to prevent leaking personal information. This is especially important in health, finance, or sensitive conversations. In terms of deployment, chatbot models are often quantized, compressed from 32-bit precision to 16-bit or 8-bit to run efficiently on edge devices or consumer hardware. Quantization reduces memory usage and inference time, making chatbot access faster and cheaper. In global applications, multilingual training is essential. Training chatbots on multiple languages allows them to converse in diverse regions, providing more inclusive and equitable access to AI. Models like GPT-4 and Gemini are evaluated on their cross-lingual abilities, using datasets like XGLUE and Flores. There's also a growing trend of data alignment research, studying how to ensure chatbots act in ways that align with human values. This includes constitutional AI, where models are guided by a written ethical framework, adversarial testing, and AI red teaming. OpenAI, Anthropic, DeepMind, Meta, and many others are investing heavily in this space, exploring how to make chatbots not just intelligent, but safe, reliable, and fair. Even beyond human feedback, some researchers are now experimenting with AI feedback loops, where one AI model critiques and improves another. This could accelerate training at scale, reducing the reliance on human reviewers while improving quality. As AI becomes more personalized, embedding-based memory will likely allow chatbots to retrieve specific user histories or preferences without storing raw data, enabling contextual conversations that feel more natural and helpful. All of this paints a picture of a technology that is constantly evolving, not just in capability, but in complexity, responsibility, and ambition. The training of AI chatbots isn't just a technical endeavor, it's a human one. Because teaching machines to talk, to inform, to comfort, to create, is ultimately a reflection of our own desire to connect, share, and understand. And the better we train them, the more clearly they reflect the best of what language and humanity can be.